Hi, fifth grade. How are you? Let me just get my presentation ready. All right. Oh, welcome back from spring break. I hope you had a wonderful Easter. So today we're going to learn about ratios in real world problems. You might be like, word problems, I don't like them. But you've been doing them actually. So I think you'll be able to do great. So the first thing we're going to do is we're going to find simplest form of ratios. So let's look at this problem. It says that there are 6 angelfish and 18 tetras in an aquarium. I didn't know what a tetra was, so I had to look it up. That's what an angelfish is, and those are tetras. The question continues, find the ratio of the number of angelfish to the number of tetras in the aquarium. All right, so you know that in ratio, order matters. So if you look at the word two in the word problem, what comes before? What comes after? Okay, and that's the order you're going to write. Okay, so you see that there are 6 angelfish to 18 tetras. So we wrote it as 6 to 18. Okay? But we're not done because you always want to put it in simplest form. Okay? So what we can do here is you can just try to find the greatest common factor between 6 and 18. Okay? If you have some trouble with that. So in here, I see that the greatest common factor is it 6? Because, obviously 6 goes into 6. Can 6 go into 18? 6 times 2 is 12. 6 times 3 is 18. Why, yes, it is. Okay. So here, I can divide this by 6. And whatever I do on one side, I have to do it on the other side. And how do I know I have to divide as opposed to multiply? Well, I want to find the simplest form. So that means I have to get my number, my first term and second term lower. So you want to divide it, okay? So this becomes 1 and this becomes 6. Okay, oops, 3. Oh, because I did 3 here, that's why. Okay, whatever I divide on one side, I have to divide it on the other side. Okay, so that was my mistake. So 18 divided by 6 is 3. Okay, so the ratio of the number of angelfish to the number of tetras in simplest form is 1 to 3. Okay, so now I would like for you to do guided practice, numbers 1 and 2, and pause the video. When you're ready, please play the video again. See you soon. Hey, welcome back. All right, so let's look at the problem that you did. There are 12 pink roses and 15 yellow roses in Bet's garden. What is the ratio of the number of pink roses to the number of yellow roses? Okay, so what's the order that I have to write it in? Well, they already wrote the order for you, actually 12 to 15. And you want to, again, write it in simplest form. So you have to divide by a common factor. It'd be ideal if you can find the greatest common factor because it'll save you some steps. But if you can't, you can just find the common factor. Luckily, the student up there in your book has helped us, and she found that the greatest common factor of 12 and 15 is 3. Okay, so you can divide 12 divided by 3, which is 15 divided by 3, which is 4 to 5. So the ratio of the number of pink roses to the number of yellow roses is 4 to 5. Now let's look at number 2. It says the ratio of the number of yellow roses to the number of pink roses. So now the order has switched from problem number 1. Okay? So yellow roses 2, the number of pink roses. It's 5 to 4, okay? And that's in simplest form. You're awesome. All right. So now we're going to look at word problems where we have to use the whole that's given to find the missing part in the ratio, okay? Um, Now let's look at this example. There are 48 children in a soccer program and 16 of them are girls. Well, the 48 children is the whole, is the entire number of children. That includes boys and girls. The girls that are given is the part, and there are 16 girls. So that means, wait a minute, who's left? Boys are left. How many boys are there? So we have to find out the number of boys because we got to look at the second sentence now. It says find the ratio of the number of girls to the number of boys in the program. We know the number of girls, there's 16, but do we know the number of boys? No, we don't. But we can figure it out because the problem gives us enough information. To find the number of boys, what should we do? What's your idea? Well, we're going to take the whole and subtract the part that we know to get the unknown part, which is the number of boys. Okay, so we have 48, which is the whole, minus 16, which is the number of girls, and you have 32 boys in the program. So now, can you figure out the ratio of the number of girls to the number of boys in the program? Remember, order matters. The ratio of the number of girls to the number of boys is 16 to 32. Are we done? Oh, thank you for the reminder. Yeah, we have to give our answer in simplest form. Remember when we were writing fractions and learning about fractions? It is ideal to always write your fractions in simplest form. Okay, and that's the same with ratios as well. Okay, we never want to leave it in any other form besides simplest form. Okay, so let's take a look. How should we write it in simplest form? Now again, you can find the greatest common factor. Okay, but if you're having trouble with that, just find a common factor. Okay, so I'm gonna start with, well, hey, I noticed 16 and 32, they're both even numbers, and all even numbers can be divided by 2. So let's see, 16 divided by 2 is 8. What is 32 divided by 2? You can use long division if you need some help with that. 32 divided by 2 is 16. Is this in simplest form? 8 and 16? No, not yet, okay? Well, let me see. A common factor I see between 8 and 16 is 4, okay? So what I'm going to do here, is I'm going to divide this side by 4 and divide this side by 4. So 8 divided by 4 is 2. 16 divided by 4 is 4. Okay. Am I finished? Is this in simplest form? 2 to 4? Not yet. There's still even numbers. Both of them are even, so we can definitely divide it by 2. Okay, so I'm going to try that. Let's see, so 2 divided by 2 is 1. 4 divided by 2 is 2, okay? And this is in simplest form because there's no other common factor between the first term and second term besides 1. Okay? Now, in your book, it was given, they found the greatest common factor to be 16. And so, do you see how you save some steps if you can find the greatest common factor. I had to do this a couple of times to get it in simplest form. But in the book, they use the greatest common factor. You can use both ways. You can use the common factor or the greatest common factor, but you might save a couple of steps if you use the greatest common factor to divide to get the simplest term. All right, so the simplest form of the ratio of the number of girls to the number of boys is 1 to 2. All right, now it's your turn. Please pause the video and try this on your own. And when you're ready, please play the video and let's see how you're doing. Welcome back. Okay, let's read the problem. It says, on a rainy day, the all-weather goods store sold 56 umbrellas and raincoats all together. The number of raincoats sold was 24. So we have to read this problem carefully because I think when I first read it, you know the first sentence? I thought there were only 56 umbrellas. But actually, when I reread the problem, it says there are 56 umbrellas and raincoats all together, okay? So that's the whole. Can you find the part in the information that's given? They tell us the number of raincoats that were sold was 24, and that is the part, okay? Now, if we go to question 3, all right, it's asking us to find the total number of umbrellas and raincoats sold to the number of raincoats sold. So, thankfully, we already have that information, so I don't need to do any other extra step to find the different part, okay? So that becomes 56 to 24, okay? Remember, order matters. It cannot be 24 to 56. It is 56 to 24 because in number 3, it tells us to find the ratio of the total number of umbrellas and raincoats to the number of raincoats, okay? So now it says equals next to 56 to 24. Why? Well, it wants us to find this ratio in simplest form, okay? So now, let's see. The greatest common factor. Well, I think right away what I see is a common factor is 8, okay? So I'm going to divide 56 by 8, 24 by 8. So 56 divided by 8 is 7. 24 divided by 8 is 4. And this is in simplest form, okay? So there's no other common factor, okay? Oh, right, this is 3, not 4, okay? Because 4, when I wrote 4 times 8 is 32, not 24. 3 times 8 is 24, okay? There we go. So the ratio of the total number of umbrellas and raincoats sold to the number of raincoats sold is 7 to 3. All right, let's look at number 4. Okay, now it says find the ratio of the number of umbrellas sold to the number of raincoats sold. So we know the number of raincoats, but do we know the number of umbrellas yet? Was that information given? It wasn't. So we have to figure that out from the whole, okay? So we know that there are 56 umbrellas and raincoats, and we know the total number of raincoats sold was 24. So we have to do 56 take away 24, and that gives us the number of umbrellas sold, which was 32. So now we're ready to input that in our ratio, okay, which is 32 to 24. Okay. And this is not in simplest form. Well, I know because in the book it says equals, and it gives us some blank spots to write a new number. So let's see, 32 and 24. Ooh, I see one right away. What about you guys? Yeah. I guess it could be 2. You can divide both sides by 2 or 4, not 6, but you can divide both sides by 8. So I'm going to do 8, okay? I'm going to divide this side up by 8, and I'm going to divide this side by 8. So 32 divided by 8 is 4. 24 divided by 8 is 3, because 3 times 8 is 24. Let me just double check. 4 times 8 is 32. So yes, this should work. And 4 and 3, there's no other common factor between them. And so this is in simplest form. So the ratio of the number of umbrellas sold to the number of raincoats sold is 4 to 3. Good job. All right. So now we're going to find a new ratio after one of the terms changes. Remember, in a ratio, we have a first term and a second term. Okay. So, for example, with this problem here, this is called the first term, and here that's called the second term. Okay. And so we're going to find a new ratio when one of these terms changes. And let's look at this example. Ernesto has 25 football cards and 40 baseball cards. He gives away 5 baseball cards. What is the ratio of the number of football cards to the number of baseball cards Ernesto has now? Well, let's see. I'm gonna just try to underline and highlight important information that might help me out here to organize my thoughts, okay? So he has 25 football cards and 40 baseball cards, okay? It says he gives away 5 baseball cards. So what changes? The number of football cards or the number of baseball cards? The number of baseball cards changes. And how do we figure out then the new number of baseball cards? Do we, what's the math we have to do with 40 and 5? Well, because in the sentence it says he gives away 5 baseball cards, we need to subtract 5 from 40. So 40 take away 5 is 35. So now Ernesto has 35 baseball cards. So what's my ratio I have to write? I'm confused with all this information. Let's go back to the information. All right, so now the question asks, what is the ratio of the number of football cards to the number of baseball cards Ernesto has now? Okay, so we have to write the number of football cards first, and then we have to write the number of baseball cards as the second term. So the number of football cards to the number of baseball cards is 25 to 35. Okay. Am I done? No. Again, remember, it's customary to write our ratios just like we do with fractions in simplest form. Okay, so let's find a common factor between 25 and 35. Well, they both end in 5, so I know they can both be divisible by 5. 25 divided by 5 is 5. 35 divided by 5 is 7. And I can double check with multiplication. 7 times 5 is 35. Check. 5 times 5 is 25. Check. 5 and 7. There's no other common factors between 5 and 7 besides 1. So 5 to 7 is in simplest form. There we go. All right. So now I would like for you to pause the video and do the guided practice for numbers 5 and 6. Okay, and play it again when you're ready. See you soon. Hey, how was it? All right, so let's take a look. It says, Gerald donated 30 quarters and 16 dimes to a charity collection. He then donated another 18 quarters. Okay, So first, let's look at the first sentence, okay? Just to wrap our minds around the information that's given. So there's 30 quarters, there's 16 dimes. Mhm. Then it says he donated another 18 quarters. So what changed? The number of quarters he donated or the number of dimes he donated? It's the number of quarters he donated, right? Okay, so let's look at number 5. Okay, number 5 says find the ratio of the total number of quarters to the number of dimes Gerald donated. Because it says then he donated another 18 quarters, we have to add the 18 to 30. So 30 plus 18 is 48. So Gerald donated a total of 40 quarters. And now, what's the ratio I have to write? Well, I have to write the number of quarters to the number of dimes that Gerald donated. So he donated 48 quarters and then 16 dimes. So the ratio is 48 to 16. And there's an equal sign. Why? Because we have to simplify. Okay, so let's see. What's the common factor between 48 and 16? Well, immediately I see they can both be divided by 8. Of course, I can see that they can, because they're both even, they can be divided by 2, right? But I see a bigger number than 2, so I'm going to go for that because maybe it'll save me a step. All right, so 48 divided by 8 is 6. 16 divided by 8 is 2. Oh, okay. 6 and 2, they're both even numbers, so I'm going to divide it by 2. 6 divided by 2 is 3. 2 divided by 2 is 1. Okay, so 48 to 16 simplifies to 3 to 1, and the ratio of the total number of quarters Gerald donated to the number of dimes he donated is 3 to 1, which is in simplest form. How'd you do? Are you guys understanding it okay? I hope so. All right, so let's look here at number 6. It says find the ratio of the total number of quarters Gerald donated to the total number of coins he donated. So now from number 5, we know the total number of quarters he donated, right? Which is 48, right? And then it says to the total number of coins he donated. That's the information we don't know yet, right? So now we have to figure out that second term. What do we need to do? Well, it says there from 5, the total number of quarters Gerald donated is 48, right? And the total number of dimes is 16. So we just have to do 48 plus 16 to find the total number of coins. And that becomes 64. So Gerald donated a total of 64 coins. Okay, and then the ratio becomes 48 to 64, like so. Okay. And let's try to find a common factor. If we can find the greatest common factor, that'd be great. Okay, immediately I see both terms can be divided by 8. So 48 divided by 8 is 6. 64 divided by 8 is 8. Okay. I'm gonna divide it by 2 because they're both even numbers. 3 to 4. Okay. Okay, so 48 to 64 simplifies to 3 to 4. All right, good job. Okay, so I had fun with you, and I hope you're doing well. I can't wait to see you on Thursday. In the meantime, just try your best and come on Thursday with questions, and I'll try to help you guys gain a deeper understanding with ratios, okay? All right, bye. I miss you. Have a good day.